Let's solve a problem about acceleration during a collision. A car traveling at 105 kilometers per hour strikes a tree. The front end of the car compresses, and the driver comes to rest after traveling 0.80 meters. We need to find the magnitude of the average acceleration during this collision, expressed in terms of g's, where 1 g equals 9.80 meters per second squared. Let's visualize what's happening in this collision. Here's our car traveling at 105 kilometers per hour, and here's the tree. During the collision, the front of the car compresses, and the driver travels 0.80 meters before coming to a complete stop. To solve this problem, we'll use the kinematic equation that relates velocity squared to acceleration and distance. The equation states that v final squared equals v initial squared plus 2 times acceleration times distance. Let's identify what we know. The final velocity is 0 meters per second since the driver comes to rest. The initial velocity is 105 kilometers per hour, which we need to convert to meters per second. To do this, we multiply by 1,000 meters per kilometer and divide by 3,600 seconds per hour, giving us 29.17 meters per second. And we know the distance is 0.80 meters. Now let's plug these values into our equation and solve for acceleration. 0 equals 29.17 squared plus 2 times acceleration times 0.80. We can rearrange this to solve for acceleration. The acceleration equals negative 29.17 squared divided by 2 times 0.80. The negative sign indicates that the acceleration is in the opposite direction of the initial velocity, but we're asked for the magnitude. So we'll take the absolute value, giving us 532.944 meters per second squared. To convert this to g's, we divide by 9.80 meters per second squared. This gives us 54.38 g's. To put this in perspective, this is an extremely high acceleration. Fighter pilots typically experience around 9 g's during extreme maneuvers, and sustained exposure to accelerations above 10 g's can be fatal. This demonstrates why car safety features like airbags and crumple zones are so important. They increase the distance over which deceleration occurs, reducing the acceleration experienced by the driver.